this example, we're going to look at some composite functions. We've got three functions up here, f of x, x squared plus 2x minus 1. We've got g such that x maps onto 2x plus 1, and we should be familiar with the idea now that this is effectively g of x equals 2x plus 1. And then our third function is h equals x squared, and recognizing that that is actually h of x equals x squared. So if we do g of f of x first, our outside function is g and our inside function is f of x. So we start with our g function, which is 2x plus 1, except it's not x, it's f of x. And then we substitute f of x. So it's 2 times f of x, which is x squared plus 2x minus 1, and then the plus 1 on the end. We distribute the 2 into the bracket to get 2x squared plus 4x minus 2 plus 1, and we collect like terms. 2x squared plus 4x minus 2 plus 1 is minus 1. When it's simplified as much as it can be, then we're finished. All right, the second one is f of g of x. So our outside function is f, our inside function is g of x. So we start with our f function, which is something squared. In the function, it's x squared, but we're actually doing g of x squared. Plus 2 lots of g of x minus 1. We make the substitution for g of x, which is 2x plus 1. So it's 2x plus 1 squared plus 2 lots of 2x plus 1 minus 1. 2x plus 1 all squared is 4x squared. 2 times 1 is 2 times 2 is 4, so plus 4x. 1 squared is 1. We distribute the 2 into the bracket to get plus 4x plus 2, and then the minus 1 on the end. So tidying that up, we get 4x squared plus 4x is plus 8x, plus 1 minus 1 cancels out, plus 2 is plus 2, and that's our answer, as simple as possible. In the next example, we've got a composite function and we're actually evaluating that function at a particular point. There's two ways to do this. First of all, you could calculate, or you could work out rather what h of f of x is and then substitute in 2 for that. Sometimes it's easier though to substitute in f of 2 first. So what we need to recognize is that this is actually h, which is our outside function, of f of 2, which is our inside function. Now, down here, I'm going to calculate what is f of 2. f of 2 is 2 squared plus 2 times 2, minus 1. 4 plus 4 is 8, minus 1 is 7. So now what we're actually doing is we're finding h of 7, because that's what f of 2 equals. From there, h is x squared, so we're substituting in 7 squared, which is 49. So that's the first way to do it, and possibly the simpler way to do it. The second way is if we do, I'll do it down here, h of f of x first. So our h function is x squared, but we're substituting in f of x. f of 2x minus 1 all squared. You can see already that if we do this purely algebraically first, we're going to be squaring a quadratic. We know how to do that via synthetic multiplication or simply by distributing each term into the brackets, but you can see that it actually ends up being quite a lot more work. So this second way, it will work, but I think the first way is probably a little bit easier to work out what f of 2 is first. All right, the last one is g of g. So g is both our outside function and our inside function. So what we're effectively doing is substituting it into itself, except it's -3 that we're substituting. So down here we'll work out what g of -3 is. And g is 2 times -3 plus 1. -6 plus 1 is -5. And so actually what we're finding is g of -5. And then we can substitute that in to the g function. So 2 times -5 plus 1. 2 times -5 is -10, so -9. Again, we can do this one algebraically. This one's probably a little bit easier, I think. So outside function is g of x, inside function is g of x. So g is 2 times g of x plus 1. So we substitute in g of x, which is 2x plus 1 plus 1. So that's going to be 4x plus 2 times 1 is 2 plus 1, 4x plus 3. And we're actually finding g of -3. So that's going to be 4 times -3 plus 3. 4 times -3 is -12 plus 3 is -9. So that one's a little bit nicer because we're not squaring a quadratic like we did in the last one. But you can see also that, they're probably much of a muchness in terms of how much work. I think this one's probably a little bit more complicated. So the top one is probably the better way to go. All right, that's enough to get you going on exercise 3D.